Good day, students. Today, I want to solve problem on the topic titled Derivation of an Expression for de-Broglie wavelengths. And de-Broglie wavelengths, de-Broglie wavelengths, de-Broglie wavelengths. Don't forget, de-Broglie wavelength equals Planck constant over mass times the speed of the electron. And we should also know that when you're solving problem under de-Broglie wavelengths, you must know that kinetic energy of the charged electron, the electron is charged, to be equals to the work done on the charge by the electric field. The charged electron, work done on the charged electron by the electric field. Why do we say that? Why do we equate them together? When electron is being charged, is in motion, there will be kinetic energy. Okay, let me give you an example. In our household electricity, you can see that the bulb glows, it lighting up, and before it lighting up, there is movement of electron in the wire. Because of that, kinetic energy takes place because of the motion, and also you equate it to the work done of the charged electron by the electric field, and the work done is charge multiplied by the potential difference, which is V naught. Okay, know that our work done equals to charge Q V naught. This is the potential difference, this is the charge, and don't forget also kinetic energy is equal to half mv squared. This is the mass of the electron, and this is the speed of the electron. And what we want to do, I want to get this expression wavelength to be equal to h over square root of 2m qv naught. And before we get that, you must know this wavelength to be equal to h over mv, which is h over mass times speed of the electron. Now let's equate kinetic energy of the charged electron, which is half mv squared, equals work done on the charged electron qv naught. Okay, and let's write it 1 times mv squared as mv squared over 2 equals to qv naught over 1, this over 1, cross multiply, and do that, it will now be mv squared equals 2 qv naught. Don't forget that we are going to make V the subject of the formula. Why do we make V the subject of the formula? The speed of the electron. We make it subject of the formula because we are going to substitute it in this expression to get the expression we're having here. You must know this in your memory, this formula. Divide both sides by m. You now have from here, now have mv squared over m equals 2q v naught over m cancel m. Now left with v squared equals 2q v naught over m. Find the square roots find the square root of both sides. Find the square root of both sides. You're going to have square root of v squared equals square root of 2q v naught over m. These two will cancel the square root. Don't forget that. Why did they cancel out? Don't forget that you have something like the v squared. This square root means half. Half will be here. These two will now cancel these two. We are left with v. That's why it cancel out. Now we now have v will be equal to square root of 2q v naught over m. Now what you need to do now is to substitute this v inside this formula. Okay, when you substitute, now go back, wavelength to be equals to h over mv equals to h over mass times, what's our v, is square root of 2q v naught over m. Is that okay? Now we have to remove this square root. Now square both sides. Square both sides. Okay, of the equation. Square both sides of the equation. When you do that, you now have wavelength squared equals to h squared over m square root of 2q v naught over m. All these ones also will be squared. When you do that, this one now be wavelength squared because h squared, this one will be squared, m squared, this one, this square root will cancel these two. Okay, this square will cancel these two. You are left with 2 multiplied by 2q v naught over m. Is that okay? These two has cancelled this square root. You are left with this. Now have 2 cancel this m because we have 2 m squared here, 1 m here, to cancel one of it. We have wavelength squared equals h squared over, that's it, 2 times m, that's 2m q v naught. Okay, this h squared, please take notes, h squared. Why do that? You now find the square roots of both sides, so that we are looking for wavelengths, not wavelength squared. Find the square roots of both sides of the equation. You now have square root of this wavelength squared equals square root of h squared over 2m q v naught. When you do that, these two will cancel these square roots. Okay, this, you can separate this square root for each of the numerator and denominator. can now have wavelength squared equals square root of h squared over square root of 2m q v naught. Are you seeing it? Now from here, this square root will cancel these two. This square root cancel these two. It's okay, because this square root is half. It's like when you're having h squared times half. These two will now cancel this. You're left with h. Now, what do you have here? You have cancelled this. You're left with wavelength, or one wavelength. You can see it. Square root of cancel these two. One wavelength. You now have wavelength to be equals to h over square root of 2m qv naught. See that this is the expression we're looking for. Wavelength equals h over square root of 2m qv naught, which is this. Okay, we have to show that the de-Broglie wavelength associated with the electron is giving us this, which is h wavelength equals h over square root of 2m qv naught, in which we have achieved. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.